Hello everyone. I want to go over the Lab 1 document that you're going to find in Chapter 2, and it's attached to this video. So if you haven't already done so, please open the document attached with this video link. We're going to discuss a few important concepts that you need to be aware of. The first document we need to discuss is the one titled Program Design and Elements for the Semester. So open it up. Okay, so if you need to pause the video to get the document open, that's fine too. But I'm going to go ahead and get started on discussing all these little pieces on the document. The first one I want to notice is Lab 1. Normally, I would go over this document in a lab setting, but our labs are going to be virtual this semester, so I'm making a video instead. So, okay, that's covered. Let's get started into the meat of the document. The first item says review 3 elements for the semester. For a review, we have 3 key elements that you need to understand for this semester. First, you need to use logic to create your algorithms. This means you create the algorithm before you do anything else. You have to think your problem through. Of course, your programming assignments will be short and fairly simple, so creating an algorithm might seem a bit dumb and time-consuming, but by following this process, you're preparing yourself for larger, more complex projects. So be sure to practice using the correct process. After you're happy with your plan or algorithm, it's time to create the actual code. This is where you open your text editor and start typing in the C++ language. You will use the machine interface, the text editor, the compiler, linker, and loader to test your code. So when you are creating your algorithm, you need to keep these steps in mind. Step 1, define the problem. In other words, really understand the problem. That means dig into it, know it up one side and down the other side. Step 2, outline the solution. It helps to break things into bite-sized pieces and then determine what the order of the events will be. You can actually plan what the program will do. You should plan what it will do, not as you type the code, but in your algorithm. Step 3, actually create your algorithm. Put it on paper. Step 4, test the algorithm for correctness. This is you reviewing the algorithm step by step to ensure it looks like it's going to work logically. That means you haven't put it in a computer yet. You're studying it. Well, you might have typed it on a Word document, but it's not in code, okay? Step 5, code the algorithm. So you take that document that you created and put on paper, the algorithm, and you take that and use it as your guide, as your map. For us, we're going to use C++ for our code. You go to your text editor. For most of you, that's going to be in Visual Studio. Some of you may use something else. And then you will actually type the code, looking at your algorithm. Step 6, run and test the program to ensure you get the desired results. Step 7, document and maintain the program. Now, this step is usually used in a work environment where the program is actually being used and someone finds glitches or bugs in it, or Microsoft updates an operating system and you have to fix it. Those kind of events, which typically don't happen in a classroom setting. Now, the next area after the steps is flow of problem solving. For programming, the flow of problem solving is input. This is where you have to determine what the input is. Where will the information come from that's going into your program? Then the process. This is where something is done to or with the input. And then last, the output. And this is where the newly created information is sent either to a screen, to paper, to both, to a file, to all three. You have to determine that when you actually create your program. All right, the next area is about doing the math. Excuse me. It's regarding the actual process step. Usually when a process is designed, it includes some kind of word problem that includes math. Math problems can be solved with generic steps. You learn them in school, K-12, right? You will use these steps plus consider the order or the flow of the computer's execution to create a pseudocode. Pseudo means fake. So essentially it's fake code because you're using plain English and not actual code. Pseudocode is used to create your algorithm. Like I said, you do not use actual code. You use plain English or pseudocode. Along with the algorithm for solving the word problems, you will include details on the variable you plan to use, any of the variables, what the inputs will be, of course, the processes that will occur in the computer, and what the outputs would be. And all of this is going to be described in your algorithm. Once you think you're finished with your algorithm, you read it over, check it for logical flaws, check to see if you need to clarify anything, see if you need to simplify any steps. Then you will use these steps to work through all your programming problems. So be sure you follow them. It's extremely important you do things in this order. All right, that's the end of our Lab 1 document, and I have more coming for you in Chapter 2.